Hello students, today we are discussing about PN junction diode is in reverse bias condition. In previous session, we have already discussed about diode is in a no bias condition and also diode is in forward bias condition. Now coming to reverse bias condition. You know already what is mean by reverse bias condition. Biasing means giving battery connection. Giving battery is a PN junction diode, then that is called as biasing. So depending upon polarities, biasing in two ways: forward biasing, reverse biasing. So here reverse biasing means a battery positive terminal is giving to N region of the diode. At the same time, battery negative terminal is giving to P region of the diode. Then that diode is said to be in reverse bias condition. So here this is the circuit. This is the circuit in no bias condition. In no bias condition, this is the depletion layer. In this depletion layer, on P side, negative immobile carriers are there. On N side, positive immobile carriers are there. So this is the depletion layer around the junction. This is the junction up to here and here depletion layer. So this total width of this depletion layer is indicating with the W suffix D. So here W suffix D is the depletion layer width, before biasing, before biasing. So before biasing, depletion width is W suffix D. Now coming to reverse bias. You know already reverse biasing means P region, N region. This P region is giving to reverse negative terminal of the battery and N region is giving to positive terminal of the battery. Then this circuit is in reverse bias condition. Reverse bias condition. And this voltage, giving battery means what? Giving external voltage to this diode. So here we are giving a reverse voltage to this diode, right? So this external voltage is indicating with the reverse voltage. Reverse voltage. Then what happened when reverse biasing is giving to PN junction diode? So here in reverse bias condition, battery negative polarity is giving to positive terminal, positive region of the PN junction diode, P region of the PN junction diode. In P region, all the charge carriers, majority charge carriers are holes and the minority charge carriers are electrons. So more number of holes are having positive charge. Okay, so P region is having positive charge of holes. So for these holes, we are giving negative charge. Positive charge of holes now connecting to negative charge of the battery. And here negative charge of electrons. Here in this negative N region, majority charge carriers are electrons. So more number of electrons are having a negative charge. So here negative charge is giving to positive terminal of the battery. Reverse. Listen careful. Positive charge of holes is connecting to negative charge of the battery. Negative charge of electrons are connecting to positive charge of the battery. Then what happened here? Positive charge carriers, holes are attracted by negative charge of the battery. And here all the electrons are attracted by positive charge of the battery. So due to this negative charge, all the positive charge of holes are attracted by this negative charge of the battery, and all the electrons are attracted by positive term of the battery. So in this condition, holes are moving away from the depletion layer. Electrons also moving away from the depletion layer. So what happened here? Before biasing, depletion width is indicating with WD, right? But after reverse biasing, these holes in this line, these holes are moving away from the depletion layer. And here these electrons are moving away from the depletion layer. So that now this immobile charge, these charge carriers are now uncovered. Why? Because holes are left out from this line and electrons are left out from this line. So these are now these charge carriers are uncovered. Now the depletion width is now from WD to, now it is increasing as WD dash. So here WD dash is the depletion width after reverse biasing condition. So after reverse biasing condition, obviously WD is less than the WD dash. Depletion width is more now. You know already, if depletion width is more, then what happened? There is no chance to movement of charge carriers from one region to other region. Why? Because depletion width is acts like a wall, acts like a barrier potential in between P region to N region. So there is no chance to movement of charge carriers from P to N as well as N to P. So that is why if reverse voltage is increases, depletion width, that is WD dash, is also increases. If depletion width is increases, the moment of charge carriers will be decreases. We know already, if a moment of charge carriers decreases, then moment of current is also decreasing. So IR is decreasing. So there you have to remember this formation. If reverse voltage is increases, depletion width is increases. If depletion width is increases, moment of charge carriers will be decreases. Obviously, there is no moment of charge carriers, current will be also decreases. Theoretically, when diode is in reverse bias condition, current level is 0. But practically, due to minority charge carriers, we can get small amount of current. Theoretically, there is no current, but practically, due to minority charge carriers, we get the small amount of current, that is called reverse saturation current. Reverse saturation current. This reverse saturation current is due to minority charge carriers. Okay, when diode is in reverse bias condition, if reverse voltage is increases, depletion width is increases, then moment of charge carriers will be decreases, then obviously current is also decreasing. But due to minority charge carriers, there is a small amount of current. That current is called it as reverse saturation current. Reverse saturation current. So this is what about a PN junction diode when it is in a reverse bias condition. Thank you.